So finding the intercepts of a function means finding the places where it crosses an axis. The x-axis for the x-intercepts, y-axis for the y-intercepts. We'll start by finding the y-intercept. It's the easier of the two to find. There will always be one y-intercept. To do that, substitute in 0 for x in the function. Now what I've done, I've changed f of x into y. Just because the y-intercept is going to be a place on the graph, y is one of the axes on the graph, so we'll change to y. Work out that calculation, and we get a y-intercept of 4. X-intercept, what we need to do is we need to find when this function is going to equal 0. So we substitute in a 0 for the y. Now, we're not going to go ahead and solve this. Because it is a rational function, we could actually have a place where the top and bottom of this function are both 0. That will result in an indeterminate or a hole in the graph and not an asymptote. We need to make sure that what we get is not a hole, that it truly is an asymptote. So to do that, we're going to factor the bottom, factor the top as much as we can. Top is the difference of squares, factors into x minus 4 and x plus 4. Bottom, quadratic, two numbers that multiply to negative 4 and add to negative 3. Well, negative 4 and 1. So what we see when we factor this, these two factors right here are identical. If we were to plug in a 4 for x, what would happen is the top would work out to 0 and the bottom would work out to 0. Indeterminate or a hole in the graph. So the asymptotes, the x-intercept will only happen with that factor. We don't worry about the bottom for the x-intercept. That was taking care of the asymptotes. So the only x-intercept we have is at x equals negative 4. Question B, a little bit easier to deal with as we don't have that fraction, but the same process holds. The y-intercept, substitute in 0 for x, and we have a y-intercept of y equals 2. X-intercept, make the function equal to 0. And we don't have to worry about any indeterminates or holes in the graph here because we don't have a rational function. We can just go ahead and solve this normally, factor that, two numbers that multiply to 2 and add to negative 3, negative 2 and negative 1, split, and we get two x-intercepts in this function. Entirely possible. Y-intercept will only ever have one. X-intercept we could have 1, 2, we could have none.